I'm going to go straight to example number 2. Atkins, go ahead and read example number 2, please.
What's the shortest distance from P to each other?
So the shortest distance is always perpendicular. So if you would, from point P, make a line that is perpendicular to the other side, for both actually. And then let's kind of see what postulate these two triangles can be congruent to. Just by looking at this, do I have a shared side?
Yes.
Yep. So we know these two are congruent to. And we know these two angles are congruent to. Are the right angles always congruent to no matter what?
Yes.
Yep. So if I were to go ahead and highlight in the tightest possible, and if y'all remember from last unit, how many are you allowed to skip a side or an angle? How many of them?
One.
Just one of them. So when I do, I have angle, skipping that side, angle, side. Or you could say side, angle, angle. So these two are congruent by angle, angle, side, congruent, or side, angle, angle. And we're not going to worry about the proof. Let's go straight to the back page. Yes, sir.
How do you know the two angles on the inside are congruent to each other?
Because it swings. How about I go ahead and make the little tick mark? We're used to the tick mark, but the textbook typically will give you one swing each or two swings each. And they mean the same thing. Okay? Yes, ma'am.
So if they're already disposable like that, then we just
Yeah, it is already congruent. All right, let's go on to example number 4. Okay, on example number 4, Emma, go ahead and read that out loud, please.
On your graph, point the plots A, -1, 6, and B, 3, 4. Write the equation of the perpendicular bisector.
All right, it says to plot it. Let's go ahead and do those two. It says -1, 6 is right up here, and also name them A and B, of course. So 3, 4 is up here. And it says to write the equation of the perpendicular bisector. So the first thing is, I need it to be a perpendicular slope. So step 1, let's first find out what is my slope. So given 2 points, let's go ahead and connect them. You can freehand draw if you want. I want to make mine perfect, because why not? Given a picture, can we do rise over run instead of using our delta y over delta x?
Yeah.
Yep. So just by looking at this, I know it is going to be negative. And what is a specific slope? -1/2. And to make that perpendicular, I need to go ahead and make that into opposite reciprocal, specifically just 2. And I'm going to box off that number to say this is what I need in the end. All right, the next one, bisector means step 2. I need to find the midpoint. Atkins, I want you to write. So it's step 2. To find the midpoint, since I gave you a picture, can we kind of pinpoint out where the middle is?
Yes.
Isn't that the middle right here?
Yes.
Now, if I don't give you a picture, should you show me the work? Definitely. But when given a graph, I think I'm going to be okay without it. And let's call this one x1 and y1. Any point that is containing is always x1 and y1. And box that off again. Given a point and slope, what was the formula that you guys use in algebra 2? Hence the name, right? So y minus y1 is equal to m times x minus x1. We are plugging in the 3 components that we found. We know our m. We know our y1. What else do I know? X1. Let's plug them in. So we have y minus the 5 is equal to 2 times x minus the 1. And then we distribute, which we get 2x minus 2. And the last thing is to do what on both sides? Add 5 on both sides to the constant. So we get 2x plus 3. And that is our final answer. Let's actually graph this to make sure it is perpendicular and bisecting. So going back to algebra 1 even, starting with a y-intercept of 3, put a dot. And our slope is understood 2 over 1. So from that y-intercept, let's count 2 over 1. 2 over 1 existing dot, 2 over 1, and 2 over 1, and let's connect. And just by the visual, it should look perpendicular, and bisected. So I have, it is perpendicular, so make your right angle symbol. Bisected, one tick mark to be consistent to say they are congruent to. So the vocab perpendicular bisector may be geometry term, but really in the end, have you done this in Algebra 1? In Algebra 2? Definitely, okay? And in case you forgot, here's for us this year. All right, on the back. If you are good at approximating, this is going to be really good for you. I might not be good at it, and that's okay, all right? So listen to my instructions on 5 and 6. And Macy, let's read number 5 real quick.
Sketch perpendicular bisectors of each side of the triangle.
All right, we're sketching a perpendicular bisector. So I'm going to need it to be a perpendicular slope, and I'm also going to need a midpoint at some point. And how you name the triangle really in the end doesn't matter, but I like to go from the top and then clockwise, B and C. Let's go back to Unit 1. How many lines do I need to make any kind of intersection? 2. But in a triangle, how many lines should there be? 3. I'm only going to stick with 2 because the third one is mainly a checking point. So I could either look at AC, CB, AB. I think I want to use CB just because it's already horizontal to me. So what I want you to do is kind of look at CB and pinpoint out where does the middle-ish look like? Somewhere over here. And if I want to make a line through this point and also perpendicular to CB, if you have your ID badge, it's ideal. But I'm going to use the corner of my card. You guys already see the perpendicular already highlighted, basically. If I line this up along my CB and stopping at that point that was kind of like approximated, I could then make my perpendicular bisector. And yes, I do want you to extend it. You don't have to. And again, if we're not good at approximating, it might be a little off, and that is okay. It's called human error. There's nothing wrong with being human. Little mistake is okay. So do you guys all see how I made it perpendicular along the line CB and just made the line, okay? Maybe if you even use your hand, you can do that too, but I want mine to be super straight. Did everyone get CB, perpendicular bisector? Okay? So what I need for you to do next is highlight that line, which is called the perpendicular bisector. Make it bold if you want. Good morning. All right. Now I can either use AB or CA. Since CA is pretty much free and has no other lines intersecting, I'm going to use CA. So if you would, make CA horizontal to your view. Pinpoint out-ish where the middle is going to go. And again, ID badge, corner of your paper, anywhere it's going to work. So what I would do is line up my CA, stopping at the point that I've approximated. So lined up at CA, stop at the point, and let's make our line. And I'm going to extend it just for the teaching purpose. And when you're done with that, highlight that perpendicular bisector. And I should also notate that it's also right angle. So do I have to make my third perpendicular bisector? No, only given 2 lines, I can find the intersection, so 2 is enough. So put a big fat dot at the intersection of the 2 perpendicular bisectors, and let's call that point D. And I'm going to give away something that you guys are going to see on the assessment. It could be quiz and or test, right? Write this out on the side. 3 perpendicular bisectors intersect at a common point called D for RD. It's called the circumcenter. Should we study that phrase before the next quiz? Might be a good idea. So if you chose any 3 lines or any 2 edges from the triangle, it's still going to give you a circumcenter. It might be off a little bit because of human error, but that is okay. All right. If you're ready for the last piece, give me a thumbs up. Okay, let's wait 10 seconds. You know I see you, right? What is this? I wonder what's under. Okay.
Maybe it's the follow.
It's so sad. Hayden, let's read the next one.
Sketch the angle bisectors of each angle of the triangle.
Okay. Let's underline angle bisector. And I'm going to name it the consistent name as the one right above. Again, how many do we need to make an intersection? Just 2. So I think I'm going to kind of pinpoint out where the angle bisector is going to be on C. I think if I make a line maybe over here somewhere and make it go through, it might be enough to say it looks like somewhat of an angle bisector. And again, it's not going to look perfect. So let's go ahead and say, here's my angle bisected. Hopefully you're not making the angle on the top too small or big compared to the bottom one. Somewhat the same.
Figure's not drawn to scale.
That's right. My figure's not, I mean, mine looks kind of bigger on the bottom. I don't know. I'm trying as you are too. It's okay. All right. Are we okay with that piece? All right. The next one. I can use A or B. I think I'm just going to go ahead and stick with the B. Just kind of pinpoint out where the angle bisector might be. It's about right here. And again, let's call that point D. And here is our conclusion. 3 angle bisectors intersect at a common point D called the incenter. And I should have been even better and had 2 tick marks with this wing.